So yesterday we talked about kinetic energy, potential energy, how we have a connection between those types and how it travels on through. So first we're going to talk about potential energy, and the potential energy is what we're looking at. We're going to look at gravitational potential energy because that is going to be a type of energy that works with gravity. But when we look at gravitational energy, we know that depends on mass and the height of an object. So it also depends on gravitational acceleration. Remember that. So this will always represent G. So G always equals 9.8 meters per second squared if we are on Earth. Otherwise, we're looking at something different. So you need to look at your potential energy. Potential energy equals mass times gravity times height. So height depends on what we are. So in this particular problem, a rock climber that weighs this much, so here's our mass, 65 kilograms, ascends a specific amount off of a cliff. Ascends means goes up. With what the climber's gravitational potential energy when we have the point of 35 meters above the cliff. So we have height is going to be 35 meters, and that equals, and we have our gravity equaling, since we are on Earth, 9.8 meters per second squared. So all we do is multiply the three numbers. So 65 times 35 times 9.8. And remember, I forgot, going back, remember potential energy. So potential energy always is in joules. Alright, let me fix that to where it shows up better. Alright, so now if we want to multiply it together, feel free to use your calculator. That's what I'm going to do. So 65 times 35 times 9.8 equals 22,295 joules of potential energy. And there's our answer. Alright, so let's do the same thing. So we're going to do gravitational potential energy. We have our mass equaling 1,200 kilograms. And we have our height of the hill at 42 meters, and of course our gravity is our constant, and that is 9.8 meters per second squared. Alright, so same thing that we did last time. So 1,200 times 42 times 9.8. So we do our 1,200 times 42 times 9.8 equals, and that is our 49. Let's read that one. 49,3920 joules of potential energy. All right, makes sense. Now moving on to kinetic energy, and we will have practice with this together after we're done. So kinetic energy depends on, so given our equation here, we are going to depend on both velocity and mass of an object. So the combination of those stand for it. So remember, kinetic energy equals 1/2 of the mass of an object times the velocity squared. All right, makes sense? So which one has more impact on kinetic energy, velocity or mass? Do you think it matters? That's for you to answer. So if a fast velocity on a small object, that means it's going to be what? Let's look at this particular thing. So we are taking half of the mass and multiplying it by the velocity squared. So this number will more likely be multiplied by the bigger number every single time. So in this case, if we look at our particular variables, we're going to see that 1/2 of the mass is what's going into our kinetic energy, but our velocity matters a lot. So a ball moving at a faster speed is going to have more kinetic energy than a baseball moving at a faster speed is going to have more kinetic energy than a bowling ball moving at a much less energy. Doesn't mean it's not going to break your foot when it hits you as a bowling ball, but it could cause death if the baseball is going fast enough. So in this particular case, if we look at our formula, so looking at the formula, we have velocity as the most impact on kinetic energy. And remember, think of it this way: kinetic energy is moving, so kinetic energy is moving, so velocity is the movement of an object, and that's why. So that should be pretty simple to follow. And let's do an example real quick. So if we take, so let's look at, calculate the kinetic energy. So let's do this. A 10 kilogram rock rolling down a hill it is going to be 5 meters per second at the bottom of the hill. So given that we have our mass, we have our velocity, so what we do is we take our 10 times 0.5, so let's put a 0 in front of there, 0.5 times 5 squared. So what you're going to have is 5 times 5 squared, as we know 5 times 25, and 5 times 25 is going to be, anybody, 125. So we have 125, and that will be our kinetic energy. And remember, kinetic energy is also in joules. So joules of kinetic energy in that specific one. So remember, Ke equals joules. So all energy is measured in joules. Make sense? All right. So clear that up. This is our lesson for today. Come grab your worksheet. Go ahead and try to finish that today if at all possible. And good luck. Let me know if you have any trouble with it.